example, to Kubernetes or something else. So it's there also. So you had three options. You had the automated ML, you had the visual interface, and you got the notebooks. Now the second one, that would be your choice now, I think.
And then there's the old studio, but my advice would be use the new one.
Yeah. Okay. Thank you.
That's all I'm allowed to say. Cool. So what you just saw was automated machine learning using a more visual interface. There's also something called machine learning.net, which is machine learning in C# actually. And what I'm going to do tonight is show you, I've got a demo as well, a lot of demo actually. I'm going to show you how to use C# to do machine learning actually. And it's good to be honest up front. This framework is in heavy development. It's changing all the time. I've got the latest preview on my laptop. It works. That's a good thing, I think. A lot of stuff is still changing. The API is sort of weird in some places, but some stuff will feel familiar to you if you used Python before and scikit-learn or similar libraries. So I'm curious, who's doing C# development today? There's a few people. Less people than on a .NET meetup. That's good news. I'm using Python at the moment for and R. Very few actually. Okay, cool. So most of the Python audio. Then this will be sort of your introduction to C# a little bit. I'm not going to syntax in that detail, but you will get an idea of what's going on, and the people that are doing C# will feel quite at home actually. So imagine that you have a GitHub and you're building something called the .NET Framework and the .NET Core version of that. And you get about a few thousand issues on this repo. And you have to specify which team is actually going to work on the issues that people post to you. As Microsoft has run into this problem. There's other open source projects that have the same problem. Of issues, if you have roughly issues open that you need to take a look at and fix and maybe classify which teams should fix it, that's quite a lot, right? So I would say this is typically a job for a developer to fix, at least the classification part, I would say. I mean, debugging all the issues there, that's something else that the teams have to do. But getting it, that's not, that you can't do it with this data. You can get an intern maybe, and ask him or her to go through all the issues that are posted and fix them basically. But that's impossible, let's be honest. So this is where machine learning shines in these kind of problems. You're a developer working on a project and you're doing your normal stuff and you run into these kind of issues. You have some problem that's unprogrammable. So if we're really naive, you could say, instead of issues to well, the old way, last year maybe. We did the data and it will classify my issues. Could work, right? A very naive strategy could be if there's something like system.io in the title, I could assign it to the AI. I could do that. But here comes the challenge. The problem might not be in system.io, but it might be related to that. System.io.port maybe. And that's a different team. There's people that are working on USB drive and Raspberry Pi. Then what? Find a new rule maybe? That could work, right? I could do that. As you can imagine, if you have a large repository, this is not going to work anymore. So comes in. Alternatively, we could say, well, let's get the old issues out of GitHub. You can do that. There's an API. Let's put them in a CSV file, including the area for the issue, the team that has to work on the issue. And based on this historical data, I can say, figure it out. Make me a function that classifies my GitHub issues. into all the areas that I know. This is a machine learning model you can run and then feed me data that anyone can post on GitHub, and I can get the data from my GitHub API into this new model, and out comes the area that needs to be assigned. This is exactly what we're going to do during this talk. Provide me with a pretty good data set for that. They cleaned everything up and made sure that it's readable. And we're going to build a machine learning model using ML.NET. So ML.NET is a C#-based machine. And you can build custom machine learning models. If you got something that can be solved using a standard model, you can use things like text recognition on Azure. There's a standard cognitive service for that. But it wouldn't work in this case because I have got custom data, essentially, and custom categories. So that's why I one for and we're going to use the command line utility that's included with the framework to build a machine learning model in an automated fashion. So what's good to know, ML is not something very new. Well, it's new on GitHub, but it's not new at Microsoft. What they told me is that ML is invested by a couple of teams for their machine learning needs. Not everything, but there are a few teams that are using it internally. So it's in that sense proven. Is it perfect? No, it's not. If you ask me, API is somewhat weird sometimes. And I will show you in a minute what I mean by that. Still, it's pretty fast. It works. So if you're in a pinch, like, this is a great solution. Microsoft is investing heavily in cross-platform source, so ML.NET is fully open source. It runs on Linux, Mac, Windows. I haven't tried it on my Raspberry Pi, but it probably runs. I'm actually pretty sure that it does, so that's pretty cool, I think. The use case that I think ML.NET will really shine in the future is using TensorFlow models. So if you have a data scientist at your company that has built a model in TensorFlow on his machine or in the build pipeline, and you can load it up in ML.NET and make predictions with that. So Python is really, really good at building readable programs. It's not so good at runtime. It's not very fast. In contrast, ASP.NET Core does 3 million requests a second. So that's a lot faster. So typically what you would do is ask your data scientist, build a model in the language that he or she prefers, and you run it in C# if you're a normal developer. So this is really cool, I think, that you can do that. A bunch of things you can build using ML. It basically does everything. Mostly the classic machine learning models, but like I said, it also does deep learning, at least it does prediction. And in the latest preview, it also includes support for actually training image classifiers, specifically using deep learning. To bother ourselves with GitHub, we're going to build a labeling tool for our issues. So before we dive into the code, let me explain a little bit about what ML.NET actually looks like under the covers. We're not going to look at the internal code. I'm just going to explain a few concepts. So people that have done machine learning or data processing, especially in Python, will feel quite at home using this API. It's a pipeline. Data goes in, it's transformed, either through pre-processing or cleaning, and then it goes through a machine learning model and out comes a prediction. Basically, the machine learning model will transform your input data into a prediction. So, for example, if I have a GitHub issue, I need to transform this issue into a set of numbers. Machine learning is all about numbers. Machine learning is text. So I have times this word happens in the say to ML.NET, I want to factorize text into numbers. That's one thing. I produce a set of numbers from a machine learning model, and I then say, well, I've got another field that I want to factorize. So first I factorize the title into numbers, and then I factorize the description into numbers. And then I can say, well, these two combined are the inputs for. So the final step in my machine learning pipeline is an estimator. An estimator could be a regression model, a classification model, binary or multi-class. Recommendations, you can do an action, you can do a number of other things. So this is the basic model. I'm changing a training set. So why is this important? Well, once you train, this estimate on the right becomes fixed. I no longer need to change the parameters in the model. I've trained those, I know the correct values, and that's it. But the first two bits, like an issue, I still need to factorize the title and the description for this thing. So basically what you can do in ML.NET is say, I'll save this whole pipeline to disk in a zip file, and the next time I need to make a prediction, I can load up this zip file, and back comes my pipeline pre-configured in the correct way using the trained model. So that way, on one computer I can create a model, and I can be sure that on the other computer, someone that uses my zip file will have the exact right setup to make a prediction. Otherwise, if he would retain these two parts, so this saving of pipelines is a really cool ML.NET. This feels slightly familiar to Python, right? Anybody notice that scikit-learn does the exact same thing? That's where I think they got the idea. Okay, so enough talking, let's do some programming. Where's my mouse? As you can tell, my computer is especially fast tonight. Is this big enough for everyone? I can bump it up if needed, but so what you see right here is my terminal. It says it's a PowerShell terminal. I've got a directory in which I have a couple of files ready. So it has a data folder, and if I go into this data folder, I've got the original file, core.fx issues.tsv, original training set that Microsoft published. But I split it into a 90% training set and a 10% test set so that I can validate my own work. I'm not going to bother you with that. Actually, to be honest, I haven't found any API in ML.NET to actually split a CSV file in a training set and a test set. Also, I haven't found any tools in there to pre-process my data and clean up all the mess that people normally produce in their data sets. So that's something that you have to ask your data engineer for, or your data scientist. Once you have the data set, you can start in ML.NET. So what you can do then is go into this command. So for people that aren't familiar with .NET Core, it used to go into Visual Studio, this lovely purple icon. That's my second OS. It takes up quite a bit of memory. And I would make a new .NET project, and it would run on Windows longer. You can do this on Mac, you can do this on Linux. That works as well. And .NET Core comes with a command line library called .NET. Cool, same thing for Python. Feels and I can say, well, .NET install a command line utility that uses .NET. And in this case, I'm going to install the ML tool. And the ML.NET tool, I have it on my machine, so I'm not going to run the command actually. It offers a rather limited set of features. So once it's booted up, it has only one command actually, auto train. It's pretty limited. But let's use it to build a model. So what I can do, I've got some demo notes to help myself. So what I can do is I can say, well, dear ML.NET, I want to train a model. I want to train a multi-class classification model. I can do regression, I can do the other one as well. Then I will feed it a set. In this case, I'm going for the time being, I'm going for the full training set of Microsoft offers. Then what I will say is -n, this I'm going to predict. I'm going to predict the area of the issue, using all the other columns that I have in my data set. Then I'll say, well, what's going to happen when I run this command? It's going to try different models and pick the best one for me, including pre-processing, including everything that you need. This takes up time. So I could give it 5 minutes, I could give it an hour, depending on the size of your data set. You might go say, well, let's spin it up for 2 minutes and see what happens. I might shorten that based on the fact that I don't have a Finally, I will say output the generated project into the SRC folder and give it a name, GitHub issue classifier. So let's see, let's modify my time for searching a little bit and run it. Oh, I'm one folder too deep. Let me run it again. So what will happen now is it starts to search for a model, and it will print out over here. That's about it, what you get. You will get a log file that explains a lot more about what's happening. Well, once this is done, I get a C# project that has 2 parts, actually. It has a model and a console application that demonstrates how to use the model, which is pretty cool, I think. What we're going to do is we're going to build an ASP.NET Core API on top of my model. Imagine you're building a microservice architecture, or you're building some application you want to use the model. So when we look at the output, in the SRC folder, I can open up Visual Studio Code, which is awfully slow. Give it a second.
Set it for expired before creating a model.
Oh, yes, indeed. We need to give it more time. Aww.
Give it a minute, come on.
Yeah. Oh, yeah, and I'm still in the wrong folder, but let's give it a minute. And the good thing is I came prepared. I have a website no, I don't. So, to be honest, this takes a little bit of time. My data set is too big for a model in 30 seconds, but you get the idea what's happening over here. Well, in the meantime, I can show you actually, I can show you the log file, which is, so this is what happens underneath. It will fire up the trainer, and if I'm not mistaken, it should be. So this will contain at the end all the logging that is output by the tool. Let's see, it's almost finished. Come on. Yeah. SRC. Ah, it expired again. Bummer. Okay. I've got a backup plan. So normally you get out a model. I did come with a backup plan, of course. You can do this by hand, you can do this automated, the result is the same. What you will get is a project that looks very similar to this. So it will output a model project, and it will output a console application. In my case, I renamed those, and I changed a few things around. So this is a one-time process. You can do this once, and it won't update your model. You have to manually train it afterwards. That's the one thing that is annoying about this solution. So when we look at the model, ignore this class, you will get an input class, GitHub issue in this case, and it's a C# class like you would expect from any normal C# application. It's a public class GitHub issue in my case. And there's something special about this. So it has the properties that were in the original data file. An ID property, don't know why that, an area, a title, and a description. Actually, these last two are the ones that you're interested in. These are the ones I'm going to provide to the model. These are marked with attributes that say, well, load the ID property from the first column in my file, and load area from the second column, etc., etc. This is how ML.NET will understand how to load your data files from disk. The same goes for the output. It has a column name, predicted label. And this actually matches my pipeline that I created. So what will happen is, at the end of the pipeline, I will have one column that contains a prediction, and I have to map this to a C# property. Otherwise, it doesn't know what to do with the data. When you use AutoML to generate this project, this is all done for you. You don't have to understand anything of that. But it's good to know that it's there, and you can use it later to customize things. So now, what do I do when I want to use this? So what's good to know for people that are a little bit more familiar with C# programming and .NET programming in general, this pipeline that I created, for only one thread. Only one person is allowed to call my model at a time. If I've got two people calling the model at the same time, which is possible if you have a website, because you have multiple visitors, then stuff will break. That's bad. Luckily, Microsoft provided a solution for that in the shape of a prediction engine pool. So what you would do is you would say to ML.NET, create me a prediction engine for my model, load my model from disk using the file, and call that directly. In ASP.NET Core, it's slightly different. The API is pretty much the same, but this is the correct way to do it in a normal application. What I'm saying, ASP.NET Core, for those that are not familiar with that, basically has a HTTP pipeline in there that you can configure. You can say, well, I want API controllers, I want pages, I want static files, I want HTTPS, all that stuff you can put into a pipeline. This pipeline is supported by a number of services, dependencies. So what you typically do if you build an ASP.NET Core application is you build a startup file for the application and specify these dependencies using configure services and the pipeline using configure. These are the two methods that you typically build. And this is automatically executed by the runtime, by the ASP.NET Core runtime, to build your web application. So what I have to do to build my machine learning service is first configure some dependencies in my configure services method. Here I'm saying, well, I want to use web pages and I want to use routing. I want to translate a URL to a page, basically. Then I will look up the model file from my application directory and say, well, add a prediction engine pool for my GitHub issue to GitHub issue prediction pipeline from this file and give it a name. What you can do is load the same model multiple times using different names. That works. I haven't used that ever, but yeah, it's there. So once I have these dependencies, I have to say, well, I have a HTTP pipeline that uses routing to translate URLs to pages. And when I have the endpoint determined for a URL, I want to use a dynamic page to display content. So basically, what happens is if I start my application using .NET Run, website, .NET Run, Let me tell you, this was one of the fastest laptops you could get. It has 64 gigabytes of RAM and it's very slow. Don't know why. And it's not charging either, so that might be the problem. Yeah, it's not charging, so interesting stuff. But it's working. HTTP localhost 5000. And this is what I get. So this is my page. I can enter a title. I can say this is my test issue. Some description. And the cool thing is, it says it's a network issue. Now, there you go. So that works. Why does it work? So I haven't shown you the last part that you need. So I've got this Razor page, which is a dynamic page that you can build in ASP.NET Core. It can contain HTML code for layout and formatting, and it can contain C# code, actually, to render dynamic pieces. So this is actually a two-part thing. It's the HTML that you see here, which is quite a lot, actually, for something so small. And there's a C# file that basically backs this page with behavior. And what I can say is, well, when you submit a form to this page, execute some code. So what I get from the client is a input form, which I've purposely bound to a input property that has the title of my issue that I want to classify and the description of the issue that I want to classify. What happens, I translate this into an issue instance and say, well, dear prediction engine pool that I created earlier as a dependency for the page, do a prediction using my GitHub classifier model and use the issue that I just created from the input that I got from the user as an example for that. What you get back is a prediction, a GitHub issue prediction instance. And that happens to have a property called area. And that's what I display in my form. So it's not a whole lot of code to get this working, actually. So what do you think? Is this something that you'd like to try sometime? I can see some nodding. Cool, cool. Quite happy. Did you know about ML.NET? Okay. You don't? No? Sort of, heard of, but never tried? Yeah. Cool. I personally feel that this is quite a good tool for things like what I just shown you, your sort of hacking projects on the side as a C# developer. This is excellent. You just use automated machine learning. Don't bother with all the numbers and balanced data sets and validation, etc., etc. It's all important for customer projects, but I would say if you're trying to fix a problem in your own development process, then it's somewhat important that it works correctly, but if it got it right 95% of the time, I'm quite happy with that. So that's how I think of using ML.NET at the moment. I wouldn't use it in production. The API, like I said, from what you've seen, it's very, very little, but there's a lot more stuff in there that you can use, and it's all pretty funky. I can show you one example. So I actually built a manual trainer. This is sort of the insight into, so here you see the pipeline, which gets nastier every minute. So I start out with an ML context, and I load some data from disk, so I can call the data property on that. And I can say load text from file, which is in a GitHub issue format that I specified earlier. And that gives me data in a streaming format, actually. So it's pretty efficient. If you have a 1 terabyte text file, it won't blow up your computer. It will be just slow. That's it. What I can then do is say, well, I've got these transformations, and I can convert a value to a key. I can say featureized text. I can say concatenate, and a number of other transformations that I can add to the pipeline. This builds the pipeline. Like I said, this is a little bit funky because what I expected actually, this data over here, I would be able to call add on that or extend or something instead of doing this. This assumes you have one pipeline. This, it might be right, but I don't know. Just so you know, be aware that this happens. That is something you have to keep in mind. So once you have this pipeline, you can add an estimator of it. And this is the trainer, and finally some output transformation. And this is basically it. This is what happens in ML.NET, even in automated machine learning. They build pipelines, they train the model, and then estimate how well is it doing. Maybe there's a better model, and try again and again and again. Does it make sense to people? Yes?
Is it also possible to do the same in Azure DevOps? Or do you have experience with Azure DevOps?
It depends on what you're thinking of in that case. So
Doing the same solution like this kind of pipelines in Azure DevOps instead of in Visual Studio Code?
yeah, you can do that. So, well, you have to build your C# program in Visual Studio Code or in Visual Studio and compile it, and then you can run it on your build server if you want to, and save the model file as an artifact that comes out of that. You can do that. But it's not like there's a dedicated task in Azure DevOps to do this kind of work. Especially, there is for Python, but there's not for C#. So that's the difference here. I think the whole story around Python is a lot farther ahead than the stuff that's happening in C#. And there's still a long way to go for C# actually. Yeah. Yes?
Do you get any model feedback, like the performance or metrics?
Yeah, actually you can. You can get that out of there. So I haven't shown you, but in my trainer program, I actually call this code cross-validate. Let me move away my mouse. I can use cross-validation. I can use normal validation methods. So if I have a test data set, I can run that through the model and see how well it's doing. And in my case, I print this out on my console, and it's rightfully a confusion matrix. When you see the output, it's no good at all. But it's just for debugging purposes and give you a sense of what's possible there. So yeah, you can do that. Yeah. Any other questions? Yes?
Is it possible, maybe in the future, from the portal we saw in the previous, use that as like a zip file?
So is it possible to export models and use it directly in ML.NET? It depends. The zip files you can't export into this format. It's not compatible. But there's a catch. So if you export what you've trained in Python to Onyx, you can definitely use it here. Project, you can save the TensorFlow file and use it in ML.NET. It's a API. That's it. Yeah. So that's why I think ML.NET is a good use case for people that want to go into production. C# is just than Python. And much easier for the C# developer. Yeah. Any other questions? Cool. No? Nice. So if you're interested and you want to learn and you like to learn more, last AI night in September, I made a tutorial. I only was able to do it with 20 people, 26. It's still up on GitHub. You can get the and it explains in great detail how to use ML.NET to build a model yourself, step by step. Actually, this model. So you can follow that, and there's videos included. So if you're confused what to do next, I've got videos up there as well. And with that, I'd like to thank you for your time.